What's the square root of negative 1?
Nothing.
Oh, but it is. Not 1. Because the square root, because 1 times 1 is 1, right? So is it possible? Yeah, but you can't do that. You can't multiply negative 1 times positive 1 and take negative 1, positive 1 squared. That doesn't work. So what the mathematicians have done is said, okay, we're going to make up an entire brand new set of numbers, and we're going to call them imaginary numbers because they do not exist, but they do. If that makes sense. They don't, but they do. And they're going to say, okay, these are called complex numbers. Okay, when you have the square root of a negative 1. Complex number system, a system that exists only to take the square root of a negative number. What does a complex number look like? It looks like this. A plus or minus bi, where A, this A right here, is your real number, and the B is your imaginary number. Just follow along from where we left off. You'll catch right on. So fill in that part of your notes. A is the real number, B is the imaginary number. That's what they're called. What do I do with this stuff? Well, let me ask you this. What's the square root of negative 1?
1.
It is called I, the imaginary number. Okay? I. The number that it goes in front. Notice how there's an I attached to the B. Anytime there's an I attached to a number, that means it's an imaginary number. Okay? What's I squared? I times I, yes. I squared.
2 I's.
Almost, not I. Well, what is I? I is the square root of negative 1, right? So don't you just take the square root of negative 1 and square it? What's the square root of negative 1 squared?
1.
Wait, hold on. I'll tell you.
Negative 1. Don't the square root and the square root cancel out? So you need to know that I squared is negative 1.
Okay. Sure.
I squared is negative 1. All right, let's do an example. What's the square root of negative 36? Well, remember when we broke down radicals?
Yes.
Okay, what do I have here? I have negative 1 times 36. Right? Negative 1 times 36? Well, what's the square root of negative 1? You guys know this. We just talked about it. What's the square root of negative 1?
I square I.
I! Okay, and what's the square root of 36? 6i is the answer. Change the square root of negative 1 to an I, and change square root of 36 to 6. Done.
Why is 1.36 I?
It's 1 times 32. Negative 1.
Oh.
Now, what about this one? We have negative 1 times 9 times 2, correct? Negative 1 is the negative sign. 9 times 2 is 18. Do I have perfect square? Do I have an I?
No.
Yes.
Sure. So I have 9 is a perfect square, so I have 3 square roots of 2i. Now, how do I graph these? Well, guess what? I didn't give you all the notes, the examples. You can just write to the side or on a separate sheet of paper. You guys figured it out?
I was looking for it now.
Yes. I just put it on, I figured you could fill it in on the side or on a separate sheet of paper. How do I graph that? Well, in a regular XY plane, the horizontal line is your X and the vertical line is your Y, right? Well, when we're talking imaginary numbers or an imaginary grid, this line, the horizontal line, is the real number. The Y-axis is your imaginary number. So we just consider this to be our X, and and we consider this to be our y. So let's graph these. 3 plus 4i. Well, my real number is 3, so I'm going to go over 3. 1, 2, 3. My imaginary number is 4, so I'm going to go up 4. 1, 2, 3, 4.
That's easy.
That's 3 plus 4i. That's it. It's pretty easy. Do another one. 3 minus 4i. I'm going to go over 3 and just down 4. 1, 2, 3, 4. Negative 2 plus 2i. Well, I'm going to go over negative 2 on the real number and 2 up on the imaginary. Any questions? That's pretty easy. Adding complex numbers. This is the same thing as combining like terms. Combine all your imaginaries and combine all your real numbers, and that's your complex number. What are my like terms here? Well, I just have 9 plus 7i plus 23 minus 21i. Well, I have a 9 and a 23 real. 9 plus 23 is 32. This is not on there. You just need to write this again on the side or on a separate sheet of paper. Okay, and then I have 7i minus 21i. Right, which gives me negative 14i. Is this written in the right form? Do I have my real number first and my imaginary number second? Yes, so this is a complex number. I could actually graph that. Now, subtracting. When you subtract numbers like this, what do you have to do first before you combine like terms? Distribute the, negative. Distribute the negative. So I'm going to have 6 plus 9i minus 12 plus 13i. Then combine your like terms. So I have 6 minus 12, and I have 9i and 13i. Is it in correct complex number form? Do I have the real number first, complex number second? Okay. This is part of it. Multiplying. What do I have to do to multiply here?
Probably distribute.
Yeah, I'm going to distribute the 3i. So I have 3i times 4 is going to be 12i. And I have 3i times negative 7i gives me negative 21i squared. I times I is I squared. Now let me ask you this. What's I squared? Go back to the front page.
1.
Negative 1. So this is going to be, that changes to your real number, and this changes to your imaginary number. So this is going to be a positive 21. And this is going to be a positive 12i. So I have 21 plus 12i because I want my real number first and my imaginary number second. So I just changed the order. I took this one and moved it here, and I put that one and moved it there. Where'd I lose you? Who did I lose?
Number.
What's that? Real number first, imaginary number second. We'll do a lot more. There's 16 pages of these.
What happened when they
I multiplied it by negative 21, and I got positive 21. Negative 1 times negative 21 gives me positive 21. This is like 12i plus 21, then I change the order. See that? Yep. What do you do when you have something that looks like this? FOIL. First, outer, inner, last. My first terms, I'm going to have 4 times 3, which gives me 12. Outer term, 4 times negative 7i, negative 28i. 3i times 3, 9i. 3i times negative 7, negative 21i squared.
Mm.
Because I times I is I squared. Then, combine like terms and replace your I squared with a negative 1. My like terms are these two. Positive 21, because negative 21 times negative 1 gives me positive 21. So positive 21 and 12, 33, then I have negative 20, oops, negative 28i and negative 9i gives me negative 19. Hi. Let's do one more of those. This is a little bit harder. FOIL, first, outer, inner, last. So I have negative 3 times 1. Negative 3 times 4i. Negative 15 times, or 15i times 1. Negative 15i. Negative 15i times 4i gives me negative 60i squared. Replace your I squared with what? Negative 1 and combine like terms. So this is going to give me a plus 60. My like terms, negative 12i minus 15i is negative 27i. Negative 3 and 60. You done? On top. Does everybody see where I got that? I took negative 16 times negative 1 and got positive 60. Combined 60 and negative 3 and got 57. Negative 12i minus 15i is negative 27i. It's a complex number. This is my real, this is my imaginary. Now, when you're dividing, we multiplied, we FOILed, we've added and subtracted. When you're dividing complex numbers, your denominators may not contain radical expressions or imaginary numbers. Okay, your denominator. What's the denominator? Yeah, the bottom number. The top one's the numerator, the bottom one's the denominator. Okay, I cannot have i's or square roots here. So I have to rewrite the problem so that I do not have any i's or square roots. How in the world do I do that? Well, you multiply by what you need to eliminate on the bottom, okay, by the radical expression or the imaginary number. Remember, I squared is negative 1. Let me ask you a question. If you multiply something by 1, does it really matter? If I multiply 4 by 1, am I still going to be left with 4? Yeah. If I multiply anything by 1, I can do that because that doesn't change anything, right? It just keeps it the same. Well, what's another way to write 1? How can I write it as a fraction?
1 over 1.
1 over 1. What's another fraction? 2 over 2.
Any number over.
Yeah, you can put any number on top of itself and get the same thing. You just get 1. And you can multiply both sides by that. Now, we'll come back to that. If I were to multiply this by 1, I would be fine, wouldn't I? Because I'd still get this. Nothing's going to change. Well, I want to replace this 1 with some sort of fraction so that I can get rid of the I on the bottom. Now, I over I. How do I know what I want to use? Well, you're going to divide by what's called the conjugate. What in the world is a conjugate? They take a fancy word and make it something that's actually really easy. When you find a conjugate, the real number stays the same. The only thing that changes is this positive, negative in the middle. Your imaginary number sign is opposite. Okay? It changes sign. So the conjugate of A plus BI is just A minus BI. Negative A plus BI. The only thing that changes is this middle sign. Everything else stays the same. That's called a conjugate. Okay? The imaginary number changes sign. So if I go back to this and I multiply it by 1, I want to multiply by the conjugate, or when the imaginary number changes the sign. Well, what's the opposite of 3i? In order to make this 1, I have to multiply the top and the bottom by negative 3i, or the conjugate. Now, marry your tops, marry your bottoms. 3i minus 3i, multiply them together, I get negative 9i squared. And then I have to distribute this one. I have 9 times negative 3i, negative 27i, plus negative 3i times 12i gives me negative 36i squared. Now, what do I do next? Yeah, replace your I squared with what? Yeah, negative 1. And rewrite it. See, I have negative 27i minus 36 times negative 1, negative 9 times negative 1. Do I have any i's on the bottom or radicals? No, that's what I want. I don't want any of those on the bottom. The way I do that is I make it an I squared and change it to negative 1. So I'm left with negative 27i plus 36 over 9, which leaves me with negative 3i plus 4. Is that written in correct form?
No.
No, what do I have to do?
Switching.
Yeah, switch the order. Put your real number first and your imaginary number second. So one. So what do I multiply both sides, or the top and the bottom by?
Negative 3i.
Over? Yeah, negative 3i over negative 3i. So I can make the bottom an I squared. So I have negative 9i squared, and I have negative 15i plus 6i squared. In order to get 6i squared, I took negative 3i times negative 2i. Replace your I squared with negative 1s. So the bottom, negative 1 times negative 9, I have negative 15i minus 6, because 6 times negative 1 is negative 6. And simplify. So I have negative 15 over 9i minus 6 over 9. Reduce your fractions. Divide both of these by 3. Negative 15 divided by 3. Now change the order so that I have real numbers first. So I have negative 2/3 minus 5/3 i. Wes, you with me? Almost done. 2 more examples, I believe. Okay, how about this one? This one's a little bit different. How do I multiply the top and the bottom by?
3 minus 4i.
3 minus 4i. Think about it. What's the conjugate of the denominator? 3 minus 4i. I changed that middle sign, so I'm going to multiply by 3 minus 4i over 3 minus 4i, because that's just 1. Now we have to FOIL on the top and the bottom. That's a little bit difficult. Okay, it's just a lot of steps. Marry my tops. Now marry your bottoms. Go ahead and distribute and FOIL the top and the bottom. This is going to give me 15 minus 20i minus 6i plus 8i squared. Divided by, go ahead and FOIL the bottom. I have 9 minus 12i plus 12i minus 16i squared. Then you just simplify. Replace your I squared with -1 and simplify by your like terms. So I have 15 minus 8, because 15, and this is going to give me -8. So 15 minus 8 is 7. Negative 20i minus 6i is negative 26i, or minus 26i. On the bottom, negative 12i plus 12i, those are just going to cancel. And I'm going to have negative 16 times -1 gives me 16. So I have 9 plus 16. This is 25. How do I simplify? Is this a complex number yet? Not quite yet. It had a real number on one side, 7 over 25, minus 26 over 25. I.
So anytime that your conjugate also has another number in it, you'll be doing a FOIL on both sides.
If it's a complex number on the bottom in the denominator, you're going to be multiplying by the conjugate, which is going to cause you to FOIL.
I remember, like, following all that out, is supposed to be related to that first one.
Okay, now I have to solve
They don't know.
for x. How do we solve this equation? Can I factor it?
No.
Okay, think of the factors of 5. Well, first of all, I have to split my x's. So I have 2x and x, right? Remember doing this a long time ago? Then I have to look at my sign, positive, it's either got to be positive, positive, or negative, negative. So I look at this sign, negative, negative. Now, what are the factors of 5?
1 and 5.
Yeah, 1 and 5. Can I multiply one of those by 2 and is the sum -3? So this is going to be, if both of them are negative? No. This is going to give me 2 and 5. If I add those together, I get 7. This is going to give me 10 and 2. I get 12. Can't happen. So what's my other option? You complete the square. Okay, to complete the square, what do I have to do? Subtract 5. So I have 2x squared minus 3x, -5. Now what? I have to divide, make the coefficient 1, so I have to divide everything by 2. So I'm left with x squared minus 3 over 2x equals -5 over 2. Now my coefficient is a 1. Now what? Complete the square. What do I add to both sides? How do I know? Negative 3 over 2 times, or divided by 2, or times 1/2, squared. So that leaves me with negative 3 over 4 squared, which is 9 over 16. No. No. I'm just going to rewrite that. Now, adding fractions. How do I add fractions? Well, I'll change this so it has a denominator of 16. In order to do that, you have to multiply by 8, so I'm going to have negative 40. That's negative 5 times 8. Negative 40 plus 9. Denominator stays the same. Now, what do I have to do? Volume form. How do I figure out what goes in here? This part right here. How do I solve for x? Square root. You guys remember this from yesterday. So I have x minus 3/4. These are going to cancel. Equals the square root of negative 31 over the square root of 16. Add 3/4. So I have x equals 3/4 plus or minus, forget that's a plus times in there. Square root of negative 31, what's the square root of 16?
4.
Yeah. How do I rewrite the square root of negative 31?
Oh, we just did that.
What's the square root of negative 31? I. Square root of 31i, right? So this is going to be x equals 3/4 plus or minus square root of 31i over 4. Is that a complex number? Ah, it is. Right?
Yes.
That's the whole point of imaginary numbers. You can get an answer. Next intercept. Any questions?
Yeah, tons. We don't have time.
Wait, we don't have to actually solve it after that?
That is solved. You have two answers. Those are x-intercepts. X is solved. You have 3/4 plus the square root of 31 over 4i and 3/4. That actually is a number. You can plug that in your calculator.
Maybe it's like the world stop. That's questions.
All right, your homework is a worksheet. I'll get those to you.
Can I go?